Assalamualaikum warahmatullahi wabarakatuh and have a great day. My name is Nurul binti Edi and my matrix number is AA211026. We'll explain briefly about the introduction of this problem-based learning PBL in ordinary differential equation DAU34403. Before reading to the question, Chapter 2, which is application of first-order differential equation, is related to this problem. This chapter can understand that the first order of differential equation can be applied to these two examples. It is Newton's law cooling and population growth. For this question, it is suitable to relate it to the Newton's law cooling. This law describes the cooling of a warmer object to the cooler temperature of the environment. Then, let's know what is the question about before we jump into filler table. As a part of your part-time job at the factory, you need to remove a metal with its core temperature of 1500 Fahrenheit from a furnace and place the metal on the table in a room that had a constant temperature of 80 Fahrenheit. 1 hour after it is removed, the core temperature is 1120 Fahrenheit. When you check the temperature of the metal, the temperature of this must be below 400 Fahrenheit before you can transfer it to the next section.
Hi, I'm Shaminaja going to present the filler table. As you can see, at the first column is the fact. The first fact that we gain is that the metal core temperature is 1500 degrees out of the furnace. The next one, the metal core then placed in a room with constant temperature which is 80 degrees. And the third one, after 1 hour being in the room, the metal core temperature dropped to 1120. And the last fact that we get is the metal core temperature need to be below 400 degrees to be moved to the next section. So the next column is the ideas. The first one, we have to find the rate of change dt per dt. The next one, we need to calculate the constant A. And the third one, we need to figure out the value of constant K. And lastly, we need to determine the statement given, whether we are able to eat lunch or not. Okay, so for the main part of the filler table, which is the learning issue, the first learning issue we get here is how do we find the rate of change dt per dt. The next learning issue is how do we calculate the constant A. And the third one, how do we figure out the value of constant K. And lastly, how do we determine the statement given, whether we can eat our lunch or not.
Assalamualaikum and hi, my name is Shamsiliana binti Suhaimi and I will present to you our result. So the first question is to find the rate of change of the temperature d capital T over dt in terms of T and Ts. Given the temperature of the metal is capital T, parenthesis time, small t and the ambient temperature Ts. By Newton's law of cooling, the rate of change of temperature dt over dt is proportional to the difference between the temperature of the metal T parenthesis small t and the ambient temperature Ts. This means that dt over dt is proportional to negative K parenthesis capital T minus Ts. So, if the soup is hotter than the water in the sink, T parenthesis small t minus Ts should be bigger than 0. Then, the soup is cooling down, which means that the derivative dt over dt should be negative. This means that the equation we need has to have the following sign pattern. dt over dt equals to negative k parenthesis t minus ts, where k is a positive constant. Next, show that p minus ts is equal to ae negative kt. So, We got the equation dt over dt equals to negative k parenthesis t minus ds. Rearrange the equation so we will get dt on both sides. dt over t minus ds equals to negative k dt. Then we need to integrate both sides, resulting in ln t minus ts equals to negative k t plus c. Next, we need to add e to both sides, and we will get e ln t minus ts equals to e negative k t plus c. E ln t minus ts equals to a e negative kt, which will leave us with only t minus ts equals to ae negative kt, where a is ec.
Assalamualaikum. My name is Nurul Alia and I will proceed to question 3 Roman. The question asks, using the observed initial temperature of the metal, T0 equals to 1500. Find the constant A, hence find the temperature of the object. Firstly, we need to find A by putting all of the information given in the equation from question number 2 Roman. So the question for A is 1420. After that, find T of the object. Just complete the equation and move Ts to the right side. The last answer will be 80 plus 1420 exponent of negative kt. Next question requires us to find constant K by using the observed temperature of the metal, that is 1120. Earlier, the last answer is T equals to 80 plus 1120 exponent of negative kt. Replace T with 1 and you will get 80 plus 1420 exponent negative 1k. The equation states that T of the object equals to 1120. Thus, in order to find K, you need to solve the equation 1120 minus 80 and multiply with 1 over 1420. And the answer is 0.7324. It is not done yet as K is still in the exponent. Use ln to solve it and K is 0.3114. The last question asks, if you remove the metal at 8:30 am, are you able to go for lunch at 1 pm? So we can use the temperature of the object that is provided in the question, and that is 400 Fahrenheit. Replace TET to 400 from the equation 80 plus 1420 exponent negative 0.3114 T. Solve it like usual and the answer is 4.79 hours. Last step is you need to add the hours in 8:30 am and we will finish at 1:49 pm. Thus, the conclusion is you are not able to go for lunch at 1 pm. That's all from me. Thank you.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Suhaila. Now I want to explain about the conclusion. Conclusion is about this study is about the of Newton laws cooling to find the rate of temperature change. The rate is proportional to find the difference in metal temperature and ambient temperature. In addition, the constant for the constant A is 1420, where it is constant against its temperature. It also have constant K, where the value of K is 0.311 E. Next, we also find that the process in this experiment takes time and follows the specified time, but in going through it, the time spent takes a long time because it needs to remove the metals to cool it. From what has been studied, the time specific is not to complete it, and that causes the lunch time to miss in this set time. Thank you. And this is all for our presentation. Thank you.